So, Janok, your last publication was about overarching view of the sequence stratigraphy.
Yeah.
So my question is, don't you think that sequence stratigraphy is now too complex, complicated, with a mess in nomenclature, and maybe biased with some concepts?
What's wrong with bias? I mean, you know, something that Darwin said is all observations must be for or against something. You know, and I tell a story, I teach to my kids, I say, look, you know, you go in the field, and you tell your 6-year-old son who has no scientific biases to collect all the information they can about the outcrop. So the child spends all day looking at where the ants are crawling on the outcrop and comes to you and says, you know, Daddy, the ants are crawling up that crack. Well, that's good information, but it has nothing to do with the origin of the sedimentary environments in which the rocks have been deposited. So the story is simply not all data are equally valuable, right? So I think so what was the question again? I lost track.
Yeah, I mean, it is very complex and complicated.
Oh, yeah, I got it. Yeah. So,
plus, we have a problem with nomenclature. We don't communicate anymore. It's very difficult. We need to build bridges and to translate terminology and other terminology in order to understand each other.
So, I mean, what I said in that paper simply was that the older lithostratigraphic approach of the 50s wasn't working, you know, and we needed something better. And it was also clear that process sedimentology got us part of the way, but not all of the way, because it ignored the surfaces. So, you know, for most of my professional career, I've been working in the science of surfaces, and there's lots of different surfaces in geology. They all have some importance, whether it's the surfaces that bound architectural elements or the larger groupings that bound the larger stratigraphic units. You know, and you know, I teach sequence stratigraphy, and I don't think people get confused when I teach it if they understand that fundamentally we're looking for the sharp contacts that violate Walther's law. Those contacts may correlate over some distance, some larger, some smaller. And if you understand the breaks in deposition that violate Walther's law, those are the punctuations in the stratigraphic record. And that embodies the history of the stratigraphic record. And sequence stratigraphy is really about interpreting those bounding discontinuities. Now, you know, you can get caught up in the terminology, but if you think process and understand that there is a product and surfaces and stuff in between that migrates through space and time, that's what sequence stratigraphy really is.
Okay, you know? So now you need a sip of your beer before answering this other question.
Right.
Which is your view of the conventional sequence stratigraphy, let's say the axon type sequence stratigraphy? Do you think that it really works if you apply the recipe? Because after all, a sequence stratigraphy is like a recipe. You have to apply that. So do you really feel that it works once you apply it?
Of course it works. I mean, if it didn't work, there wouldn't be all the papers about it, you know. I just finished a major project, and perhaps to my surprise, the Exxon method worked perfectly. Now, the method worked perfectly to identify all the key surfaces, and I visited with Exxon, about a month ago, and they looked at the data and said, wow, this is really fantastic. They said, now, we might name some of the surface differently, but we would draw all the same surfaces in. I said, you know, there's two real issues. Do you fundamentally correlate the rocks differently, so you have a different idea of what is age equivalent to what, or do you have all the same surface, and then you just get into an argument about whether this should be the sequence boundary, that should be the sequence boundary? If it's the former, then you've got a serious scientific problem. You don't know how to correlate the rocks, and there's disagreement as to what correlates with what. That's a problem. But if you're just arguing about whether or not you should use the flooding surface as the sequence boundary, and you've got them both drawn correctly, and it's just an opinion of which is important, you know, that's what I call pissing in your coffee cup. You know, that's not moving forward. That's just arguing about whose words are better than the other ones, right?
Yeah.
So the issue is, do you have a scientifically robust analysis of the stratal relationships, and then you can talk about how they form, or do you actually not really understand how the rocks fit together? If you don't know how the rocks fit together, then you're not using the tools correctly. If you're just arguing about, you know, which surface is more important than the other, then you're basically in a trivial argument, you know, and I think an enormous amount of ink has been spilled on the trivial arguments of sequence stratigraphy, ignoring the real value of it, which is an improved way to understand how to correlate facies and rocks in time.